The Home Pros Radio Show.
Welcome to the Home Pros Radio Show podcast. I'm Tommy Donovan with RIC Home Inspections and your co-host for the Home Pros Radio Show. The home building industry is continuously evolving as we work to develop more innovative methods to manage our living spaces. Relatively new to the heating and air conditioning scene, geothermal heating systems have become an increasingly popular heating and cooling option for homeowners. First added to a residential setting by an Ohio State University professor in 1948, geothermal heating systems have slowly gained worldwide acceptance over the years thanks to the oil crisis of the 1970s and the development of more economically viable building materials such as polybutylene and polyethylene piping. As of 2004, there have been over 1 million geothermal heat pumps installed in homes worldwide. Currently, there are about 80,000 systems being installed in homes across the United States each year, and we've seen advertisements that boast the benefits of this highly efficient and environmentally friendly energy resource. But one question still lingers for the average homeowner. How do these systems actually work? To help clear the air on this topic, we had the pleasure of having Steve Weitzel from Water Furnace and Scott Kelly with Carolina Heating join us in the Home Pro studio to explain.
And I'm excited that you guys are here in the studio. We've got Steve Weitzel here with Water Furnace. Tell us about geothermal heating and how does it work? What is it all about?
If you just take the word geothermal and we dissect it, the word geo means earth and thermal means heat or energy. And so a geothermal system taps into the energy that's stored in the earth. Our planet is the biggest solar array that exists. At least that we know of, right? Mm-hmm. And when the sun comes up every day, our planet absorbs that energy, and it stores it 6 feet below the ground. And so a geothermal system, what it does is it taps into that energy that is 6 feet below our feet. That's why we say it's the buried treasure or hidden treasure buried beneath your feet. And so what we do is we take that stable earth temperature, which in South Carolina, it's about anywhere from 67 down along the coast, up to 64, 63 here in the upstate. And we tap into that energy source. And that is a source of energy that we use to do a heat exchange with the Freon.
Explain this to me like I'm a 2-year-old, okay? Because there's an element to this thing I just cannot get through my head.
Exactly. One of the most exciting things I have as a home inspector is the opportunity to explain just what a heat pump does and how it works, because it is tricky. It's the same thing with geothermal. I had to really study the diagrams, back it up. When we're talking heat exchange, we're really just it's a matter of exchanging. We're talking about exchanging temperatures, energy. Heat is energy from one medium to another. So we're using the heat that's only 5 or 6 feet deep under the surface of the earth. And then how are we getting that warmth into the home?
Okay. Well, great question. Let's talk to everybody like they're a 2-year-old.
Yeah, exactly.
So this technology, I like to refer to it as caveman technology.
Okay.
It's been around since caveman days. Why did early man live in a cave? Well, it was warm in the winter and it was cool in the summer. And the reason for that is he lived in the earth in a rock formation. And that's what geothermal is. So what we use is water is the medium that we use to transfer this heat from one place to the other. A heat pump, all it does is move heat from either out of your home into the ground or out of the ground back into your home. And so water is the medium that we use to transfer that heat. If you think about a blacksmith, when he heats up metal, he doesn't cool it by waving it around in the air. That's what a basic, ordinary, entry-level air conditioning system that most people have are using to transfer heat. They're just waving that heated metal around in the air. A blacksmith takes that hot metal and puts it in water, and that water moves that heat 25 times faster than air.
And we were getting into the nuts and bolts of how it works. You know, we're talking about harnessing heat energy from the earth and getting it into our home. How do we do that? We've been talking about using water to do that. Scott, tell us a little bit about how that works.
Yeah, so geothermal systems, the heat exchange portion of it has to be engineered. We have software that helps us do that. been doing this so long, I used to have to do it longhand.
Yeah.
So, but now we have computers, makes it pretty easy, computer program. And it also has to be designed for that region. And then the soil type. We're trained to identify different soil types. So if we're in an area where you dig 2 feet and you're in solid rock, we can't do a horizontal loop. We have to do a vertical loop where we take a drill rig,
Go straight down.
Or if we're on a real small lot, I'm talking about maybe a house, which you got a yard that you could cut with a weed eater.
Yeah.
We typically have to use a vertical system. All of our heat exchange is done with plastic pipe. This pipe is of the same quality as gas piping that the utilities use. They're plastic pipe. It's a polyethylene type product.
Is it like PEX?
No,
like in plumbing?
No. PEX is a cross-linked. It's a polyethylene, but it's cross-linked. Ours is polyethylene designed specifically. It's got a mix. It's designed specifically for the geothermal industry.
Okay.
So we either design it for a vertical loop, horizontal loop, which is less costly typically.
And the easy way to think about that, folks, is vertical loop. You're digging straight down into the earth. Horizontal, you're going about 5 or 6 feet deep.
That's correct.
Almost running like a drain field, like with a septic system. You're just kind of going around the yard and then bringing that line back in, and these are closed loop systems, which everything is enclosed with the circulation.
And then we do have a third loop.
Mm-hmm.
That's called
a pond
loop or a lake loop. If you live on Lake Hartwell, the Corps of Engineers will not let us put them in there. If anyone's listening from that area, Duke Energy will let us put it on their lakes.
Which would include Kiwi.
Kiwi, yes, mm-hmm. Kiwi. We've got dozens and dozens of systems in Lake Kiwi. If you own your own pond, it needs to be about 8-10 feet deep. The depth is more important to us than the actual surface area of the pond.
So when you send that loop around, so folks, when we're thinking about this loop, it's kind of like your air conditioning. If you have a split HVAC system, you've got refrigerant lines that are working with your air handler, which is in your attic or crawl space or in your home, and then your condenser outside, and you've got this circulation of refrigerant going through. When we're talking about these systems with the geothermal, you've got your HVAC system in the home, and we're sending basically a water line out into the yard, or to a pond. Like if we were to do it at Lake Kiwi, we're obviously going to want to go beneath the surface of the we want to go beneath the lake.
Oh, yes.
Any lake. Actually, it's not like the pipes are going out where you can swim up to them.
The pipes are actually...
Are they exposed?
They're in the lake. They are exposed.
Okay.
Duke has specific guidelines for us to follow to enter and exit the lake.
Okay.
You will not see the lines coming in and out of the lake.
You're not going to hit them with your propeller or anything.
That will not happen. Mm-hmm. But they're plastic coils of pipe that's in the lake. And then we do have another loop. It's not really a loop. It's called an open system. Mm-hmm. We don't promote those so much, but that is the least costly way to get a geo system. But if you have a well and it's got enough water production, you could heat and cool your home with that. But what a lot of homeowners don't understand is the volume of water you're going to be using. You could use 1 million gallons of water a year easily to heat and cool a 4,000 square foot home. And you're depleting the aquifer.
The resources.
Yeah.
Because that's the reason why it's called an open loop, because you're pulling that water out and then disposing of it, right?
Yeah, just dumping it somewhere.
I gotcha. Well, that's one of the things that is certainly a plus with this type of a system, is it's all natural. We're not using any combustible or we're not using any natural resources that we would deplete.
That's correct.
We're just using the environment to heat our homes.
It's a very green product. Very green.
So I would assume it's very efficient at doing its job.
It's going to save a homeowner 30 to 60%. And it also will heat some of the domestic hot water in the home.
Yeah.
Almost free of charge.
Yeah. Wow. So it's nearly twice as efficient as a traditional system, is what I've read about. And the process involved with installation, if you kind of like what I was getting at with the generator system, if you have an existing home, how extensive is it?
Well, the footprint that we work in with a vertical system is a lot smaller. We could work within a 10-foot by 10-foot area with the vertical. But when we do horizontal, it's about 200 feet of trench per ton. So that's, you have to have half acre up, depending on the size of the house. And, of course, now we're talking about doing something landscaping-wise.
Yeah. Do it right before you lay sod.
It's a good time of year to do it.
Hey. Yeah. Just a quick question. How deep do you go with the vertical? I'm just off the top of your head. I mean, is there a certain standard?
For us, of course, we can do most any depth. For me, the deepest I've ever been is 600 feet. Typically, we do 100 to 300 is more typical.
I got you.
But we have had some water wells go dry, and instead of just capping that off and not using it, we've been able to use that as a geothermal hole.
I got you.
As with any new technology, there have been some myths that have materialized regarding geothermal heating and cooling systems. Jay Egg with Egg Geothermal addresses these myths in an article he posted at nationalgeographic.com. He says that some folks believe that since geothermal systems do use electricity, that they should not be considered a renewable technology. The fact is that geothermal systems use only 1 unit of electricity to move up to 5 units of heating or cooling from the earth to your home, so the electrical consumption is very minimal as compared to other options. Another myth is that geothermal systems require a large amount of yard or real estate in order to install your circulation lines. As you heard in our discussion, there are horizontal or pond loops that can be used to install your circulation lines, and these could take up some yard space. But if your lot size is limited, a vertical loop is a perfectly viable option that can be installed on even the smallest of lots. In this article, Jay Egg also notes some added benefits of geothermal heating and cooling systems. Aside from their efficiency, this clean energy source is very quiet. For example, there is no outside condenser unit like our traditional HVAC systems use that can run rather noisy and can have a tendency to bother our neighbors. Also, once installed, a geothermal system can actually last for generations since all of the equipment is protected indoors. When equipment does need to be replaced, the expense is much lower since there is no need to replace the entire system. With all of this in consideration, you can see how the long-term benefit of owning a geothermal heating system can save you money. As for the initial installation, geothermal systems start at around $5,000 per ton of heating and cooling capacity. Standard systems start at around $3,000 per ton. Simple math can reveal the money saved with a geothermal system over time. Also, new installation practices are continuing to reduce costs to the point where the cost is getting closer to conventional systems. Also, there are federal and local incentives available that typically amount to 30 to 60% of the total geothermal system cost. That can often make the initial price of a system very competitive with conventional equipment. For more on geothermal heating and cooling systems and how they work, we recommend this book, Modern Geothermal HVAC Engineering and Control Applications, co-written by Jay Egg, Greg Cuniff, and Carl Oreo. It's available on Amazon.com. You can also contact Scott Kelly at Carolina Heating for more details and assistance with installing a geothermal heating and cooling system in your home. You can find more details from Carolina Heating at carolinageoheating.com. We've also included a direct link to their website in our show description for your convenience. Special thanks also to Steve Weitzel from Water Furnace for his assistance with this podcast. That's all the time we have for this podcast. I'm Tommy Donovan with RIC Home Inspections. Please take a moment to leave a review to let others know about the helpful information we share on our show. Also, click subscribe so you can keep up to date with every new episode of the Home Pros Radio Show podcast as it's released.
Thanks for listening to the Home Pros Radio Show. Meet more Home Pros at homeprosradio.com. There, you can also catch full episodes of our show, along with additional information to ensure that your home is in perfect shape. It's the Home Pros Radio Show, brought to you by Prime Lending, home loans made simple. The Home Pros Radio Show, online at homeprosradio.com or on the radio at 94.5 WGTK, The Answer.